The sun emits energy in the form of light and heat. Solar energy is fundamental to weather phenomena and life on Earth. Solar radiation warms the planet's surface. Solar radiation drives processes like evaporation. Solar energy influences global temperature patterns. The sun's energy warms the Earth's surface unevenly. Uneven heating causes temperature differences that drive wind and ocean currents. This uneven heating is a primary factor in creating diverse climates and weather patterns. Solar heat causes water to evaporate from oceans, lakes, and rivers. Evaporation transforms liquid water into water vapor. This process is essential for the water cycle and cloud formation. Water vapor rises into the atmosphere. In the atmosphere, water vapor cools and condenses around tiny particles, forming clouds. The condensation process releases heat. Released heat influences atmospheric conditions. Clouds consist of numerous water droplets, or ice crystals suspended in the atmosphere. Cloud formation is influenced by temperature, humidity, and the availability of condensation nuclei. Condensation nuclei act as surfaces upon which water vapor condenses, initiating cloud droplet formation. Rising air cools and expands, causing water vapor to condense and form clouds. Rain occurs when water droplets in clouds become too heavy to remain suspended. Rainfall is a crucial part of the water cycle, facilitating water transport from the atmosphere to the earth. Rain replenishes freshwater sources, such as rivers, lakes, and groundwater reserves. Rain supports plant life by providing essential moisture for growth and survival. In cold conditions, water vapor in clouds freezes directly into ice crystals. These ice crystals form snowflakes, showcasing a variety of complex shapes. The unique structure of each snowflake depends on temperature and humidity during its formation. Wind is the movement of air caused by differences in air pressure. Air pressure differences are typically due to uneven heating of the Earth's surface by the sun. The sun's uneven heating of the Earth's surface creates areas of high and low pressure, leading to wind. Global wind patterns are influenced by the Earth's rotation and the distribution of land and water. These patterns play a significant role in distributing heat around the globe. Global winds also distribute moisture, influencing precipitation patterns worldwide. Weather fronts are boundaries between air masses characterized by differing temperatures and humidity levels. The interaction of contrasting air masses at weather fronts often results in dynamic weather changes. Weather fronts can cause significant shifts in temperature and humidity. Storms are a common consequence of weather front interactions. The Earth's axial tilt causes different hemispheres to receive varying amounts of sunlight throughout the year. This differential sunlight exposure leads to distinct seasonal changes in temperature. Seasonal changes also affect precipitation patterns, influencing rainfall and snowfall amounts. Wind patterns are also influenced by seasonal temperature and pressure variations. Different regions of the Earth have distinct climate zones based on average temperature and precipitation. These climate zones support different types of ecosystems. Climate zones significantly influence human activities and settlement patterns. Thermometers, barometers, and anemometers are used to measure temperature, air pressure, and wind speed, respectively. Weather instruments provide essential data for accurate weather forecasting. Accurate measurements of temperature, air pressure, and wind speed are fundamental to understanding atmospheric conditions. Weather forecasting involves analyzing current atmospheric conditions and using computer models to predict future weather patterns. Analyzing current weather conditions is the initial step in weather forecasting. Computer models simulate atmospheric processes to predict future weather patterns. Accurate weather forecasts help people prepare for and mitigate the impacts of severe weather events. Severe weather events, including hurricanes, tornadoes, and blizzards, can cause substantial damage and widespread disruption. Understanding the atmospheric conditions that contribute to severe weather is essential for effective safety measures. Preparedness strategies, such as early warning systems and emergency response plans, are vital for mitigating the impact of severe weather. The water cycle is the continuous movement of water on, above, and below the surface of the Earth. Evaporation is a key process in the water cycle, where liquid water changes into water vapor and rises into the atmosphere. Condensation occurs when water vapor in the atmosphere cools and changes back into liquid form, forming clouds. Precipitation is any form of water that falls from the atmosphere to the Earth's surface, such as rain, snow, sleet, or hail. Runoff is the flow of water over land surfaces, eventually making its way into rivers, lakes, and oceans. Clouds are classified based on altitude and appearance. Cumulus clouds are puffy and often associated with fair weather. Stratus clouds are flat, featureless, and can bring overcast conditions. Cirrus clouds are thin, wispy, and often indicate approaching weather changes. Atmospheric pressure is the force exerted by the weight of air above a given point. Atmospheric pressure is directly related to the weight of the air column above a specific location. Changes in atmospheric pressure can indicate approaching weather systems. High atmospheric pressure generally indicates stable weather conditions. Low atmospheric pressure often indicates unstable weather, such as storms. Humidity refers to the amount of water vapor present in the air. High humidity levels can make the air feel warmer than the actual temperature. Increased humidity contributes to the formation of clouds and precipitation. Air masses are large bodies of air characterized by relatively uniform temperature and humidity. Air masses originate over specific regions, acquiring the temperature and humidity characteristics of the underlying surface. Air masses influence the weather of the areas they move into, bringing their temperature and humidity characteristics. Weather maps employ symbols and colors to represent various weather conditions. Temperature, precipitation, and wind direction are commonly visualized on weather maps. Weather maps are used to visualize weather patterns and forecasts. Climate change refers to long-term shifts in temperature and weather patterns. These changes are primarily caused by human activities that release greenhouse gases into the atmosphere. Increased greenhouse gas concentrations trap more heat, leading to a rise in global average temperatures. Weather conditions significantly impact agriculture, affecting crop yields and food production. Extreme weather events can damage crops and disrupt agricultural supply chains. Variations in temperature, precipitation, and sunlight directly influence plant growth and development. Weather patterns influence the distribution and behavior of plants and animals within ecosystems. Changes in weather conditions can disrupt ecological balance. Weather changes can pose a threat to biodiversity within an ecosystem. Understanding weather phenomena is essential for making informed decisions about daily activities. Preparing for severe weather events relies on understanding weather patterns and forecasting. Addressing the challenges of climate change requires a deep understanding of long-term weather trends and atmospheric science. Continuous observation and scientific research are crucial for improving our knowledge of Earth's atmosphere and weather systems.